All right, we're back taking a look at question 3. The graph below illustrates the position and time for a dog that runs to catch a stick and returns with it. The dog caught the stick after 2 seconds. You could see it went, caught it, and then, came back. Okay? So what we need to know is the average speed as it returned. So that's pretty simple for you guys to find. Average speed, once again, you know it's on first formula on your formula sheet, distance over time. Simple, simple, simple. But the only trick of this is keeping in mind it's for the return, when he returns. So this part of the graph where the line's going down, since this is position, not velocity, position over time. So basically the position, the distance decreasing, all right, not the velocity decreasing. So that's the only tricky part, getting the information from the graph. So if we look at this graph, we could see the dog went up to 7 meters and then came back 7 meters. So we're only considering the coming back part. So coming back 7 meters, all right, that'd be my distance. Coming back 7 meters over the time it took to go back 7 meters. So I'm not going to use, this is a common mistake, people use the full 10 seconds here. Nope, we're only going to use the coming back part, which is from 2 to 10. And the amount of time from 2 seconds to 10 seconds, you should know, is 8. If you don't believe me, just do 10, take away the 2 seconds that don't count, you'll get 8. So you end up with 7 meters over 8 seconds, which gives you about 0.9 meters per second, which is answer B. All right, so now what we're going to look at is the soccer players. So they're kicking the ball back and forth, player X, player Y, some interesting names there. And it shows you how far they kick, distance and direction right here. And basically you got to find the total displacement and total distance. Okay, so the thing to remember is distance is how far in any direction. Okay, whereas displacement is how far out of place, which means how far from the start. So there's a difference. How far from where you started versus how far in total. So let's go ahead and look at this data and figure out our distance, how far in total. So we go 5 right. So I'll just go 1, 2, 3, 4, 5 right. Okay, this represents 5 meters right. Okay. Now 4 left, kicked back 4 left. So right from here, 1, 2, 3, 4 left, right? So we did 5 right, 4 left, now 6 meters right. So right from where I started, right here, I'm going to go 1, 2, 3, 4, 5, 6 meters right, okay? And then back 5 meters left. So again, right from where I ended up here, I'm going 5 left. 1, 2, 3, 4, 5. So I really just need to add up the total of that. So I could just add it here. 5 plus 4 is 9. You add 6 to that, that's 15 plus another 5. So we have a total of 20. I could add my little dashes here to see. But what the dashes help me to see is really how far am I from where I started. I started here. I ended here. And, technically this is all on one line, but it'd be hard to see if I just keep going back and forth. So I drew it a little bit down. But you could see I'm 1, 2, right? I'm basically 1, 2 away. So I'm 2 over to the right. I started here. I ended here. That's 2 meters to the right. That would be my displacement. So that's my delta x, my displacement. This is my distance, total distance. So obviously you can see the answer. The only answer that matches that is A. Don't get tricked by B. Has the same numbers, but they're in the wrong spot. The displacement's not 20. That's the distance. The distance is 20, and the displacement is 2.